for Year 10 Methods Pathways. We're going to look at the practice test for certain indices. This test was given to you while you were doing revision for the certain indices test. It can be found on Simon, the certain indices tab on student resources. Okay, so let's start off with question number 1. Okay, we're specifically looking at questions like these. Okay, so these questions. So these questions are to do with finding numbers with fractional indices on them. Okay, because the index, the power is actually a fraction. So let's go revise what a fractional indice is. Okay, so if I have the square root of a, we know that's a to the power half. If I have the cube root of a, that's a to the power third. If I have the fourth root of a, that's a to the power a quarter. If I have the nth root of a, then it's a to the power 1 on n. So 49 to the power negative a half is going on that idea, except we also combining with the idea of negative indices. Remember, if I have a to the power negative 1, I can move the a to the power negative 1 downstairs, and what do I do? What's the effect? The power turns to a positive 1, except, you know, when we write a to the power 1, you don't write the 1, okay? So if I add a to the power negative a half, that I can move that a downstairs, so it'll become a to the power half, okay? So a similar idea here. If I got 49 to the power negative half, I can move the 49 and a half downstairs, and it becomes a positive index. Okay, now we need to know what anything to the power half means. It just means the square root of it. So square root of 49 is the same as 7. So 1 on 7 is the answer. Similar idea, if we got 9 to the power 3 on 2, I can rewrite that as a half times 3, because half times 3 is 3 on 2. Now, I have a choice here. I can raise 9 to the power half first, or raise 9 to the power 3 first. Okay, and then, you know, you still have to do the other one, but the order in which you do it matters. 9 to the power 3 is a lot harder to do, because you have to mentally computate what 9 times 9 times 9 equals to. Okay, that's a big number. I know my 9 times 9 times 9 timetables. So an easier way, far easier way, is if you go 9 to the power half first. Well, we know 9 to the power half is just the square root of 9. Okay, we can work out the square root of 9. But we've still got the 3 there, so it hasn't gone away. We're just doing the half first. So square root of 9 is 3. 3 to the power 3 is 27. So the idea is you always want to do the root part first, then do the power, okay, or then do the whole number power, because it's just easier and nicer to do. Another example I can quickly do is if I got 4 to the power, or no, not 4 to the power, 8 to the power 4 over 3. Now 8 to the power 4 is a huge number, because it's 8 times 8 times 8 times 8. I don't know how to work that out, so you can break it down into a third times 4, because 4 and 3 is the same as a third times 4. So 8 to the power third is the same as cube root of 8, and we're raising it to the power 4. So cube root of 8 is 2, 2 to the power 4 is 16, because it's 2 times 2 times 2 times 2, 16. Okay. Now let's look at another question. We're going to look at question number 7. Okay, this is to do with indices. Okay, so we're looking at indice fractions. Now the idea behind these indice fractions is we want to simplify it, and we want to make sure our answers have positive indices only. Okay, first step, let's deal with the numbers first. I always want to deal with the whole numbers. Okay, I'm not talking about the powers, the whole numbers. So we know 12 and 6 both go into 6. So 6 goes into 12 twice, 6 goes to 6 once. Okay, so great, it ends up being a 2. M2 divided by M4. Remember when we have bases divided by each other, the same base divided by each other, we subtract the indices. So that's M2 minus 4, which equals M negative 2. So we've got 2 m negative 2. Now I leave it at the top, okay? Because when you've done this fraction, just leave it at the top. Don't second guess yourself and put it at the bottom yet. N4 subtract 2 is the same as N4 or 4 plus 2, because you got a double negative. 4 minus 2 is the same as 4 plus 2, so we got N6. So that simplifies to this expression. Now we want positive indices, so we don't want to get rid of the M2, but we want to change it so that it's positive. The only way we can do that is if we move it downstairs, so it's M2 like that. Okay, so when we move a negative indice downstairs, you change the sign of the indice so it becomes positive. Similarly, if I had an indice downstairs that's negative, I can move it upstairs to make it positive. Okay. All right. Part B, question B. I want to simplify this. So the index law we're going to use is if we got a times b to the power 2, that's a2, b2. We distribute it evenly. Similarly, if I had a on b to the power 2, you distribute it evenly on the numerator and the denominator. Okay, so we're using the similar idea here. So we're distributing the 2 evenly in the denominator and numerator. So 4 to the power 2, a to the power 2 times 2, 4, b to the power 3 times 2, 6, and bottom line, 3 to the power 2, a to the power 6, because 3 times 2 is 6, 2 to the power 3, a to the power 3, b to the power 6. 8, the 8 is not affected by any powers, and then b to the power 14. Now we're going to simplify all this, okay? First of all, I want to work out what the numbers are. 4 squared is 16, a 4b6 times 2 3 is 8, 8 cubed times b6 on 9a6, 8b14. Okay, let's work this out. 8 goes into 8 once, so that goes away. 16 and 9 don't go into anything, so you're going to have a 16 and 9 left over. Okay. Now let's do the A's, and I'm going to do a few steps in one. Okay. So I'm going to combine the A4 and A3, because A4 multiplied by A3 is A7. You add the indices. So we got A7 at the top, we got A6 at the bottom. So A7 divided by A6, you should get A only. Okay, because 7 minus 6 is just 1. So A to the power 1 is just A. Then we do the B's. B6's B12. B12 at the top, B14 at the bottom. So 12 minus 14 is B to the power negative 2. Now you can put the negative 2 at the top at the start, or you can just go, oh, I know that's B negative 2, so I'll just put it at the bottom, so it'll be B positive 2. And that should be your answer. Okay. If you're not comfortable with doing the steps in your head, you can write another line. That's okay. But I know these questions can take quite a while if you do that. If we look at question C, so we got 2 to the power 4, and I'm doing this in my head. 2 to the power 4 is 16, f to the power negative 4, g to the power 8. Now, since we have a divide here, remember the rule is if you have a divide, you can change it to a times, but you have to flip the fraction, okay? So that become 3f at the top. And you always flip the second fraction, so don't ever flip the first one. And I'll expand this as well while I'm at it, so I don't have to write a gazillion lines. 2 to the power 3 is 8, g to the power 9, and then over here is 6f2. Now, I know that 8 and 16 go into each other, so 8 goes into 8 once, 16 twice. 3 and 6 go into each other, so 3 goes into 3 once, 3 goes into 6 twice. Okay, can you see I have a 2 at the top, 2 at the bottom? They both go into each other once, so they sort of get rid of each other. Now, what else can I get rid of? Alright, so I'll do the counting on the f. So I've got f neg 4 and f1, so that's f neg 3 at the top, and then f2. So neg 3, f neg 3 at the top divided by f2 at the bottom. So negative 3 minus 2 is f negative 5. So we've got f negative 5. And the g's, we've got g8 divided by g, which is 8 minus 1, which is g negative 1. Okay. And we don't have any numbers left because they've all been divided into each other. Now, since these both are negative indices, we need to change it to positive, so I'm going to move them both downstairs. Now, if you got nothing at the top, you just put 1 there, okay? So you've got F5G1, like that. All right, let's go through question 8, A and C. So these are the same type of questions, except we've got fractions now, fractional indices. So the same law applies to fractional indices. Okay, so you do the subtraction, you do the multiplication, you do the addition. It's same idea, okay, except the only difference we've got fractions. So T4 over 3 divided by T, when we multiply 2 by a third, we get T 2/3. Okay, so since we're dividing something on the same base, we subtract the indices. 4 over 3 minus 2 over 3. 4 over 3 minus 2 over 3 is 2 over 3, so it's T 2 over 3. Okay, we're done. Part C, let's do this one quickly. We got W 2 times a third, which is 2/3, x to the power third on W to the power third, times W a third times times 3 is, if you got thirds and you multiply by 3, you just get 1. Okay, so Wx to W. Now I can do some cancellations just so that I'm not adding too many crazy fractions together. W goes in W once, so they go away. All right, we'll have to bite the bullet with the rest. Okay, so let's do. We got W 2/3 at the top, and we combine the x's. So we got x a third, and x is like x to 1. So a third plus 1 is the same as a third. Well, we need to get the 1 into thirds, so that's 3/3. So 3/3 is 4/3. Okay, so x to the power 4/3 divided by 2w a third. Okay, so the only thing we can simplify is the w's because we're dividing. So same base, we're dividing indices, we're subtracting 2/3 minus a third is a third. So we've got w a third, x to the 4/3 divided by 2. So that's basically how you work it out. Hopefully that helps.